Okay, welcome to the video for 8-4. This is actually a quick lesson. What we're doing is we're trying to find the sum of an infinite geometric series. So that basically means we're looking for any sum that goes to infinity right there. And we actually talked about this a while ago. Do you remember Zeno's paradox with Achilles and the tortoise? And remember how Achilles and the tortoise were going to be in a race, but the tortoise got to start 10 meters ahead of Achilles. And when they were allowed to start the race, in the time it took Achilles to go 10 meters, the tortoise went 5. In the time it took Achilles to catch up with the tortoise, those 5 meters, the tortoise went 2.5. In the time that it took Achilles to do those 2.5, the tortoise went another 1.25. In the time that it took Achilles to do 1.25, the tortoise went another half of that, 0.625, and so on, right? And Zeno's paradox was, how come Achilles will never actually reach the tortoise? Because the tortoise will keep moving a half more, and every time Achilles tries to catch up with the tortoise will have moved a half, right? And we know in the real world Achilles is faster than the tortoise, or a human should be faster than the tortoise. But it turns out it's also a sum of infinite geometric series because we can just add up. Let's say the tortoise started at 1, and then he went a half, and then half of that, and half of that, and half of that, and so on, right? So the fractions never end, but we kind of understand that all of this is going to equal 2. So we're going to learn the formula for that right now. So take a look at page 437. And first, the core concept at the top of the page, the sum of an infinite geometric series is the first term all over 1 minus the common ratio. I hope you have your calculators ready. So let's take a look at number 1 at the bottom page 437. This is an infinite geometric series because it has a common ratio, which we're going to have to find. And at the end of it, you notice that, we have the ellipsis, ... Alright, so first, let's take the common ratio. We're going to do the second term divided by the first term. So we're really doing 4 over 25 divided by 2 over 5, which means that we're going to multiply by the reciprocal, and we'll simplify. 5 goes into 25 5 times, 2 goes into 4 twice, so our common ratio is 2/5. Let's check our work though. 2/5 times 2/5 should be 4 over 25, and it is. 4 over 25 times 2/5 should be 8 over 125. 4 times 2 is 8, 25 times 5 is 125. So it's correct. Always check your common ratio, especially if you're shaky with fractions. So now we just need to fill in the formula. We're going to take the first term, which they give us, it's 2/5, and we're going to do that over 1 minus the common ratio, over 1 minus 2/5. And now we just have to simplify. So 2/5 is on top, and well, 1, that's kind of like 5 over 5. So 5 over 5 take away 2 over 5 is 3 over 5. And then we're going to multiply by the reciprocal of the denominator, and we notice that the 5's cancel out, which is a coincidence. So the sum of this geometric series that starts at 2/5 has a common ratio of 2/5 and goes on to infinity. It actually all adds up to 2/3. Okay? So that's when they give it to us when it looks like a series. Now, what if they give it to us in summation notation? So there's the sum of a series from 1 to infinity of -1 over 2 to the n minus 1. Alright, so things that I need. Since the formula is the first term all over 1 minus the common ratio, I need the first term. So for that, I'm just going to plug in the first number. Okay, sometimes it's 1, sometimes it is not. You have to look. Plug in the first number for n. 1 minus 1 is 0. Anything to the 0 power is 1. So my first term is 1. Now my common ratio, well, they give it to us. It's the base. So 1 take away negative 1/2. Alright, so now I need to clean this up. 1 over 1 take away a negative, that's 1 plus 1/2 is 3/2. And I'm going to multiply by the reciprocal. So one more time, for some reason, my common ratio is 2/3. Then for number 3, the sum from 1 to infinity of 3 times 5 over 4 to the n minus 1. Alright, so again, my formula is the first term all over 1 minus the common ratio. Well, when I plug in the first number here, and keep in mind, make sure the first number is 1. It might not be 1. You plug in the first number. So the first number is 1. 1 minus 1 is 0. Anything to 0 power is 1 times 3. 3 is my first term. My common ratio is 5 over 4, so 1 minus 5 over 4. Well, that's like 4 over 4 minus 5 over 4. So I have 3 over 4 minus 5 is negative 1 over 4. And I'm going to stop there, actually, because I realized something that I didn't write down. The common ratio is 5 over 4. 5 over 4, the absolute value of it is bigger than 1. And if your common ratio's absolute value is bigger than 1, the infinite sum does not exist. So all this was for nothing. In fact, let me go back up here. That's if the absolute value of the common ratio is less than 1. Because if the absolute value of the common ratio is greater than 1, then it does not exist. There is no infinite, there's no sum to the infinite series. Does not exist. Okay? So number 3, I actually did too much work because I didn't identify and make the connection in my head that 5 over 4 is bigger than 1, so it doesn't exist. Alright, let's try one more. Number 4. So here's another one just written as a list of terms added up. It's infinite because there's an ellipsis. The sum is the first term all over 1 minus the common ratio. So in this case, well, first term, that's easy, 3. But what is my common ratio? I'm going to do the second term. I'm going to divide it by the first term. Second term divided by first term. I'm going to make that 3 over 1. So those of you that are having trouble with fractions, instead of dividing by 3 over 1, we're going to multiply by 1 over 3. And voila, the common ratio is 1/4. Before I go any further, though, I'm going to check my work. Is 3 times a quarter 3/4? Yes, it is. Is 3/4 times a quarter 3/16? Yes, it is. Alright, so that is correct. So 3 over 1 take away a quarter is 3/4. And I'm going to multiply by the reciprocal again. 3's cancel out. The sum of this infinite series, the sum of this infinite series is 4. Okay, let's go back to number 1 for a second before we move on to the last part, because they're actually going to have you break some stuff down. Number 1, if you remember, it was 2/5 plus 4/25 plus 8 over 125 plus 16 over 1625, and so on. Now it said find and graph the partial sums for the first 1, 2, 3, 4, and 5 terms. Okay, so basically they want us to know what is the sum of just the first term. All right, so if I add the first term to nothing, it's 2/5. What is the sum of the first two terms? Okay, so the first two terms are 2/5 plus 4/5, or sorry, 4/25. So I'm going to get my calculator out. I'm going to make sure I do math to fraction, and I get 14 out of 25. What's the sum of the first three terms? Okay, so that's this plus this plus this. So I'm going to add 8 over 125 to my last answer. Make sure it's in fractions. They give it to us in fractions. We need it in fractions. What's the sum of my first four terms? So that's this plus this plus this plus this, or I'm going to take this sum, I'm going to add that onto it. Math to fraction. Oy. These are numbers. I guess we should not discriminate. And then finally the first five terms, I didn't write down this time, but I should have. The fifth term, so 1 plus 2 plus 3 plus 4 plus 5 terms, the sum of the first 5 terms. Well, if this is correct, I can just add that onto it. Math to fraction. Oop, it's not even given to me as a fraction. So that's going to come out to approximately 0.6441. And I think that I'm okay with that at this point, because the calculator is not giving it to it, but you gave me these as a fraction. So that's the first 5 partial sums. They're partial because for the sum of the first term, you're only looking at that. Sum of the first two terms, you're only looking at that part. Partial sums, because that's the sum of the first 3 terms, is only that part of the sequence, and so on. And then they wanted you to graph it. So that requires some very specific graphs. Let's see. Sum of the first, sum of the first 2, sum of the first 3, sum of the first 4, sum of the first 5. How about we do 1/5, 2/5, 3/5, 4/5, and 1. So the first one is 2/5. The second one, well, that's almost 15 out of 25, so that's almost 3/5. 75 out of 125 is probably, you know, that would probably be 3/5, so it's pretty much above it. Oh, 200 out of 325. I don't know. See how I'm just rounding the numerator? Well, it comes out to about a little bit more. And then finally, this is 0.64. Okay, so my figure is definitely not drawn to scale. But as this goes up, it looks like it's not really getting above. The book has it very much more specific, but it looks like it's never getting above 4/5. It's something closer in the book, but not too much problem. We can see that it starts leveling off, though. You add another fraction onto it, and it doesn't go up that much more. It goes up just a little bit. So that's what happens when you graph it. Okay? So that's how to find the sum of an infinite series, geometric series. Remember, if the common ratio, the absolute value of the common ratio is greater than 1, then the sum of the infinite series does not exist. You can give me that. You can give me that. Okay? All right. Now the last part, and I know this video is going long, but that's okay. The last part's actually really kind of simple. So they want us to write repeating decimals to fractions. Now this is actually really good if you ever want to grade papers, and if you do, let me know. So the first one is 0.55 repeating. Now, first thing you need to do is identify how many digits are repeating. Okay, it's just one digit that's repeating. So if it's one digit that's repeating, you're going to put that digit over 9, and that's your answer. Let's take a look at number 7. Alright, so they give us 0.727272 dot 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 dot. So how many digits are repeating? Well, it's the first two that are repeating. So 72 is going to go over 99. Two digits repeat, two nines in the denominator. That's your answer. Alright, so that means that number 8 is going to be 0.131313 dot dot dot. First two digits repeat, so 13 over two digits, two nines in the denominator. So let me give you one, just so that you are confident. What about 0.123123 dot dot dot? It's the first three digits that are repeating. So 123 over three digits, three nines in the denominator, and that is how you convert a repeating decimal into a fraction. Alright, there's work assigned to you. Do your best with it, and let me know if you have any questions.